Good morning, dear sir and madam. I am Dr. Abhinandan Ratre. I am from IIT BHU Varanasi and I am going to present my one of the accepted papers in PEMD 220, and the title of my paper is Reduced Voltage Stress, Extendable 17 level multi-level inverter using single DC voltage source. Presentation I will discuss about introductions about the MLIs, and in that scenario I'll discuss about the conventional multi-level inverters and the title of the proposed topology, and the descriptions about the different switchings of proposed ACMLI switched capacitor based multiple inverters, and then the switching and capacitance of the proposed ACMLI, and after that the comparison with the recent published topologies with the proposed one, and then experimental validations, and finally the conclusion. What is the inverter? So inverter is a power device that converts from the DC to AC conversions, and here the simple sinusoidal pulse width inverter. And then what is multi-level inverters? So these are the special type of inverters which can generate the multiple output voltage levels from to achieve the desired AC output voltage. This is the waveform of the conventional multi-level inverter. What are the advantages of the MLIs? It generates the low electromagnetic interference, and the TSD, total harmonic distortion of the overall structure, is reduced due to the staircase waveform, and efficiency will be high and switching frequency is also low, and filter size is reduced because the harmonics are reduced due to the average sinusoidal output voltage, and the voltage stress across is reduced, and then operating voltage will be also for MLIs will be high. The conventional level is divided into three parts. One is the neutral point clamped, and where the diodes are, or it is also known as diode clamped. Here the diodes are used to clamp the output voltage, and then the flying capacitors. Here the capacitors are used to generate the output voltage levels, and then CSB MLI is cascaded. Here the different series connections of power modules are used to generate output voltage levels. And what are the drawbacks of conventional MLIs? The in neutral point or diode clamped, like the more number of diodes are present, so which restricts the negative flow of the current. So the for a low power factor operations it will be very difficult because it is the reverse blockage of the power is obtained. And then flying capacitors, or the other large number of capacitors are used to generate output voltage levels, and due to presence of large number of capacitors, the balancing is a inherent problem. So these are the main disadvantage of the flying capacitors. And then cascaded HPC, due to large number of DC voltage sources, the cost of the overall structures of the proposed inverter will be very high because large number of DC voltage sources are required. Then some proposed solutions. One proposed solution is the hybrid SMLI. Here the some of the voltage sources are replaced by the capacitors, and there is also a demerit of the capacitor voltage balancing. Then couple inductor based MLIs are project, but due to bulky inductors, the size and cost of the MLIs will also high. Then due to advanced research, the switched capacitor based MLIs are generated, and here the capacitors are self balanced. No inductors are required to boost output voltage, and capacitors are self balanced, no need of external circuit, no need of additional voltage sensing circuits or signal condition circuits are required to balance the capacitors in this switched capacitor based SMLIs. The main drawbacks is the large number of SMLIs, or the large number of active and passive components are required, and the peak inverse voltage of the switches increases with the increase in voltage levels. As the PIV increases, then the cost of the switches also increases. So to reduce the cost of the MLI, so we have to SMLIs, we have to minimize or the PIV at a less level, and the total standing voltage of the switches also increases the cost of the switches. So the breaking down of the title of the proposed structure, the reduced voltage stress. Here the voltage stress across all the switches is not more than the input DC voltage or VDC. All the switch voltage stress across all the switches will be inside the input DC voltage, not more than the VDC. It can generate 17 level output voltage levels, and switched capacitor, the series parallel combinations of the capacitors are utilized to produce different voltage levels. And this is the proposed 70 level SMLI structure. Here you can see that these are the peak inverse voltages. This is the red rail square shows the peak inverse across all the switches. Here you can see that the PIB across all the switches are within the VDC, or one or less than one VDC. So the peak inverse voltage is of the SMLIs are within the input DC voltage source. The single DC voltage source are utilized and the three capacitors are self-balanced, inherently self-balanced because the structure of the proposed SMLI, that VDC and VCA is VDC by 2 and VCB is VDC by 4. Then the current path for the 1 by 4 VDC, this is the 17 level voltage levels and switching angles of the proposed 17 level SMLI, and this is the 1 by 4 VDC. The current path of the sub-circuit of the overall SMLI. 1 by 2 VDC, the current flow path, and this is the 3 by 4 VDC. Here you can see 3 by 4 VDC. This is the VDC only. The 5 by 4 VDC structure, 3 by 2 VDC. This is the 7 by 4 VDC we obtained from the overall structure. It's a 2 voltage gain is 2. Switching scheme. The selective harmonic elimination technique is used to generate the switching angles, and these are the 8 switching angles are used, and the switching angles are obtained from the selective harmonic elimination techniques and obtained are as follows. And here are the 3 capacitors are used. The capacitor values are also find out by using the charging and discharging cycles of the switched SMLIs, and it is calculated mathematically and obtained as follows. This is C1, CAB, CB. 3 capacitance values are given. Then the comparison with other SMLIs. These are the some recently published switched capacitor SMLIs and compared with the proposed SMLI. Here you can see that the PIB of the proposed structure is 1, and as compared to other SMLIs, recently published SMLIs, and this is the and TSB, total standing voltage or total blocking voltage, which is equal to sum of the voltage stresses across all the switches or devices. 16.5 bit is less than all other proposed SMLIs, and you can see that a single DC voltage source is utilized. So these are the advantages of the proposed SMLI as compared to other proposed SMLIs. Then the experimental validation are as follows. The 500 watt prototype is developed experimentally, and the experimentation has been carried out using the DSP processor, and input DC voltage is taken as 100 volt, and fundamental switching frequency is 50 Hz, and a modulation index is taken as 0.8, and the capacitance ripple is taken as 10%, and here are the 3 capacitance values are calculated using the previous formula as given in the previous slides. These are the experimental validation. Here you can see that output voltage, 17 level output voltage are obtained experimentally, and this is the RMS voltage is 135.4 and current is 3.37 for 40 ohm resistance, and the TSD is found around 6.75 with this stage without any filter. So this one stage is obtained without any filter from the experimental. These are the capacitance, the 3 capacitance BC1, BCB, BCB from C from experimental validation. You can see that capacitance are cell balanced, and the capacitance are 98 volt, 47 volt, and 23 volt. So all the capacitance are according to the theoretical validations, theoretical calculations. So the capacitance are self-balanced without using any external circuit or additional circuitry. Then dynamic performance of the proposed structure is also validated. Here is the load resistance is changed due to the step down change in load change. Here you can see that the current is changed but output voltage is constant because all the capacitance are self-balanced. So there is no change in output voltage. So this shows the dynamics behavior of the overall structure. In the conclusion, a 17 level SMLI reduced voltage stress using lesser number of active passive components using single DC voltage source is presented, and it has been observed that PIB across all the switches and diodes within the input DC voltage and capacitor balances has been achieved in the proposed structure without using any additional circuit, and the performance of the proposed SMLA has been validated experimentally to 500 watt prototype. This is the reference that has been utilized for the paper. Thank you.